Okay, good afternoon, all of you. My name is Sonali Shinde. My paper ID is 050. My paper presentation topic is Secure Machine Learning Classification Algorithm for Cloud-Based Remote Healthcare Services, and guided by the Satish Gujar sir. The introduction of this paper is: as more and more people use healthcare data analytics, the method of classifying data has become very important. A data classifier is usually made and then sent to a cloud. Then a service provider can easily offer a wide range of services and deal with a lot of classification requests from the user. With the privacy and security issues, the valuable classifier and sensitive user data cannot be directly sent to the client. We focus on the Navy bias NB, which is one of the most popular classifier. We show how to outsource NB classification in the cloud in a way that is both efficient and private. Especially the service provider can change the traditional NB classifier into fixed hyperrectangle, and order preserving encryption is used to encrypt this hyperrectangle as the encrypted classifier, so the service provider can use the encrypted classifier. After that, the encrypted classifier is sent to the cloud, and user can send encrypted queries to the cloud and get the classification result back. That means there are the three entities in remote clinical healthcare services, that is healthcare center, cloud server, and the end user. First, the healthcare centers build a decision model from its medical data set by using Navy bias classification technique and submit decision service model to the remote cloud server. Second, third-party cloud server handles massive and frequent healthcare services requests from user and provide healthcare decision based on their medical features. Next, literature review. First paper is AI assisted prediction on the potential health risk with regular physical examination record. This paper was published in 2018. The conclusion of this paper is improve the good solution for the mismatch of inefficient medical resources and rising medical demand. Second paper, using electronic health record for surgical quality improvement in the era of big data. This paper was published in 2015. The conclusion is the proposes a collaborative filtering inspire approach to predict the inappropriate access. Third, similar disease prediction with heterogeneous disease information network. This paper was published in 2020. In this paper, author proposes a method to predict the similarity of disease by node representing learning. We first integrate the semantic score and topological score between disease. Next paper is Health Assistant Bot, a personal health assistant for a Italian language. This paper was published in 2020. Present health assistant bot, an intelligent virtual assistant able to talk with patient in order to understand with suggest doctor and monitor treatment health parameters in a simple way by exploiting a natural language based interaction. The system allows the user to create her health, describe her symptoms, to search for doctors, or simply remember a treatment to follow. Next paper is the a medical history based potential disease prediction algorithm. This paper was published in 2019. This paper intends to healthcare big data analytics combined with deep learning technology to provide patient with potential disease which is usually neglected for lacking of professional knowledge, so that patient can targeted medical examination to prevent health condition from getting worse, inspired by the existing recommendation method. This paper proposes a novel deep learning based hybrid recommendation algorithm which is called as the medical history based potential disease prediction algorithm. Next, this is the proposed system design. In this, first the healthcare center builds a decision model from its medical data set and it's sent to the cloud server. Here the patient medical data information store. After that, the on the patient medical data pre-processing is there. Data pre-processing is the process of preparing the raw data and making it suitable for the machine learning model. After that, the feature selection is there. Feature selection is the process of reducing the number of input variable when developing a predictive model. After that, the classification is there. Classification is refers to a predictive modeling problem where a class label is predicted for a given example of input data. For the classification, we use the Navy bias classification algorithm. Navy bias is the supervised learning algorithm. Next is the proposed system. Data classification is one of the most important big data analytical techniques. It can be used to make accurate prediction for unknown data samples, which can help a wide range of applications such as online disease diagnosis and vehicular intelligence. Many different types of data classification functions, which are owned by a service provider, can be sent over to third-party cloud server for easy configuration and management. At the same time, user will get better service because the cloud has powerful computing and storage ability. Navy bias is one of the most common classifier, especially for online diagnosis services. When a hospital outsources its NB diagnosis classifier to the cloud, it can provide online diagnosis service and patient can send their medical information to the cloud and get a diagnosis prediction afterward. The mathematical model of proposed system is S is equal to IFO. I stands for the set of inputs. The input consists of this set of disease data set. It is uses clinical data set. F stands for this set of functions. In F, there are the F1 for data extraction, F2 data pre-processing, F3 feature extraction, F for classification. That means this set of functions we use for the classification. Next, online O stands for clinical services. Next, Navy bias algorithm. Navy bias algorithm is supervised learning algorithm, which is based on Bayes theorem and used for solving classification problem. It is probabilistic classifier, which means it predicts on the basis of probability of an object. Navy bias classifier is one of the simple and most effective classification algorithm, which helps in building the fast machine learning models that can make quick prediction. Bayes theorem is also known as the Bayes rule or Bayes law, which is used to determine the probability of hypnosis with prior knowledge. It depends on the condition probability. The formula for Bayes theorem is PAB is equal to P in bracket B summation A PA divided by PB. PAB stands posterior probability, PBA stands likelihood probability, PA is prior probability, and PB is marginal probability. The conclusion of this paper is, in this paper, we have to come with a way to keep machine learning classification scheme safe in the cloud. In the proposed scheme, the secure outsourced Navy bias classification problem is changed to a secure range query problem. Then order preserving encryption are used to keep data private. Both security and performance tests show that our scheme is very efficient while protecting both data and the classifier. Also, experiments show that our scheme is very efficient in terms of computational overhead. It only takes a few microseconds to encrypt an NB classifier. Thank you.
Which parameter you consider for Navy bias theorem?
Patient
From your data set?
Patient information. Patient enter the information. This information consists for Navy bias classification.
There are a lot of patient information. Then which particular features you consider for this?
By using the Navy bias algorithm, we classify according to this algorithm. Classify according to the Navy bias algorithm. This algorithm is used for only for the classification.
Okay.
Using this formula, we can classify.
Any question from any other session chair member? Yes. Yes, sir.
Actually, I have a small comment. Presentation was very good. However,
Yes.
when we are attending, this is just again a suggestion, don't take it positively. The main theorem which you were revolving about, it's not pronounced as Navy bias.
Okay.
If you would be kind enough to even search on Google,
Yeah.
it's Naive Bayes.
Naive Bayes.
So,
Okay.
so if it's the European names which are pronounced differently. So it just for as a suggestion, when you're going to go, I understand, to higher education and international universities, this is a very big setback that we make mockery on international stage, I would say. So please don't take it as a negatively. It is just a comment, a slight suggestion and recommendation to be as clear in pronouncing the words as much as possible, because when you're attending international conferences and you have to go a long way, for now it looks good. And when you say yes, it's not yes. I'm not picking on English, okay? So please don't mind it. When you say yes, it sounds as, okay, are you agreeing with me? Yes. It's not yes. So please work slightly, I would say, on it, because the whole meaning for certain words would change during your future presentation. And when you go for higher education, in case you go abroad, you will really, I am telling you from my experience, of course, I was from convent school in my schooling days, but you would work months and months together and you would be humiliated in international crowd. So that's why I am saying what I am saying for all the participants, all the presenters. Please be very careful. Please work hard, and please stay away from getting mocked on the platform. When you say yes, it is why yes. You say S. You have to work on it. There is no way around. And it's naive base and not Navy bias. It sounds as NAVY Navy, which is like Army, Navy, and Air Force. And bias is like BAIS, which is an electronic word, bias. So anyway, other than that, very nice. I appreciate your confidence and the spirit with which you presented. Good luck to you.
Thank you, sir.
Very welcome.
Thank you, sir. Thank you,
Well-
Sonali, ma'am. Thank you for sharing your thoughts and knowledge with us.